Hey, what is good, everybody? Welcome back to the channel. In today's video, it's all about dynamic arrays slash lists, or whatever you guys want to call it. In the previous video, essentially what we did was, well, what did we do in the previous video? Actually, I don't remember. Yeah, I don't remember. It's been a while. Probably, I don't know. Yeah, I don't really remember. Let me run this and see if there's anything in the console. Perhaps how do I run this slash bin app um library not loaded. Actually, this is something we need to fix. Yeah, we actually need to fix this because currently when I want to run my project, I have to cd into the bin directory and then do a dot slash app, and then it runs the app, right? But unfortunately, I don't want to keep on having to do this manually. So what I'm going to do is I'm going to cd out of here back into the root directory, and what I'm going to do, I'm going to go down to our makefile, and in here, essentially what we're going to do is we're going to fix the issue whereby it says, let me just do it, bin slash app. We're gonna fix this issue that says library not found when I try to run it outside of the bin directory, right? So in order to fix that, I think it's right here. Yeah, we have to remove this and replace it with our path, and I'm just gonna say executable path like this. Yeah, it's a macOS thing. I think if I do that and I save and I try and build this again, and then I just do dot slash bin slash app, it should just run the app. Yes, it works. So that basically fixes the whole library not found situation. And then the other thing is we want to automatically run this thing immediately after building, right? So I'm just gonna come up here to the all command, and I'm just gonna, oh yeah, I think I already, yeah, okay, fine. I guess it was already there. But yeah, I'm just going to put run there. And then what I'm going to do is down here, I'm going to say phony. I'm just going to run, define that command, and then just do this dot slash bin slash app. Okay. And then what's going to happen now is when I save this and I come down to my console and I clear this up again and I just say make, it'll compile and then it'll run automatically for me. Okay, so that's another improvement to our build system. It will just run the application immediately after running. And then I also just want to quickly clean up this whole console situation. I want to get rid of this, and I believe all of that stuff is in the platform macOS layer, and all I need to do is just search for ns log, and it will say application launched, so we know that this is working, so no need for that anymore. And then there's the other one, failed to create application delegate. Okay, I don't want to get rid of that. Content scale, yes, this is the one that we want to remove because we know that that is actually working. And let me just save all of this. And then we just come back to our main .c file, and I think everything is perfectly fine here. So I'm going to clear up this, and I'm just going to rerun this again, and then boom, voila. So now we have a much cleaner console now. And also, let's just get rid of this hello world. It's kind of outdated now because everything else is sort of working. And I would also just get rid of the debug prints as well. And then if I just sort of clear up, let's quit. And then we clear up our console. Sorry. Then we make again, and now we should be seeing something like this, right? However, when we're building our thing, we get this whole junk that I don't want to see. So let's go back to our makefile, and let's just omit all of that. So in here, next to clang, just put an at sign, I guess. That will just mute it, right? It won't print all this junk that we see over there. So let me just quit the engine again, and then clear our console, and then make. And I think now it should just be quiet, and we should only be seeing what's being called and then the engine running, right? So our event system gets set up successfully and our input system is initialized. So I think in the event system, I can actually just, where are we doing all of this? Event system initialized. We don't have to say successfully anymore because we don't have to do that. And I just want to clean up the input dot And put that C1 as well. Just get rid of that exclamation mark. Probably just put a dot maybe, and then do the same for what is this? Where is it? Over here. All right, sweet, nice. So if I just quit this and I clear all of this and I make this again, you'll notice that everything now is clean and consistent, and we have a much better build system. However, this build system is actually not efficient because it recompiles every single C file, no matter whether or not it has been changed or not. In the future, I'll probably just do this off camera actually, and then just update it so that it can only compile the files that I actually changed. That way it will speed up our compilation time and everything will run smoothly. Okay, but I'll do that off camera, and then I'll just sort of like give y'all the yeah, what I did, so that you guys can just copy paste if you want. So yeah, so back to what today's video is about. Let's just get back to dynamic arrays. Oh, all right, so what are dynamic arrays? So essentially in C, we don't have the concept of vectors such as in C++, right? Because in C++ we have what we call vectors, and vectors essentially just, you know, containers that can basically pretty much hold any type of data and then basically scale, and then allow you to basically push and pop items, etc., etc., right? So in C, we don't have none of that. We basically have to code all of that stuff ourselves, and this is what this video is about, right? So we're gonna basically develop dynamic array for ourselves, which we will basically use in the engine itself, right? So what we're gonna do is we're gonna have a dynamic array or a dynamic list. I don't know what we want to call this, but yeah, I'll just stick with an array for now. And what this array is basically going to have is essentially, it's just going to basically, or how it's going to function essentially is that we basically just going to create a container. So this is the container itself. And then within this container, we're going to have memory, right? The first few blocks of memory will be allocated for the header, right? I'm going to call it a header. And this header essentially is going to hold metadata, okay? So it's going to hold metadata for our container, right? So if you look at the code here in the event.c, this struct essentially has some form of metadata within it, right? It has the count, the number of elements, and the capacity, and then it has the list itself. So you can think of this struct as the header. So we're going to basically allocate space for that struct header here, and then the rest of the memory will then be used to essentially store what is this? To essentially store items, right? Yeah, essentially that's it, right? It will just be used to store items. So we'll basically have, like, you know, the items that we want to store in this dynamic array, like so. And one cool thing about this now is that instead of us having to manually increase the size like we are doing down here, where is that function, resize event array, we will basically have this dynamic array do that for us automatically. So if it runs out of space, like for example right here, and I want to add like an item to the list, and this item doesn't have space, so then the array itself will essentially just scale itself up, right, and then make space for this new item. But it won't just scale so that we can just fit one item. Instead, what it'll do, it will see, okay, how many items do we have? It'll be like 1, 2, 3, 4, 5. So let's just double that, and then let's just create capacity for 5 more elements, you see? And then from there, we can basically store 5 extra elements before we have to essentially resize again. So we have to store another 5 more elements, and then once we get here again, and we'll be like, hey, I want to store a new item, so I don't have space for that. So let's see, how many items do we have? We have 10 items, so let's just double that. So now we'll have extra capacity for 10 more items for us to essentially store in this array. And then we can just keep on adding items until we've added 10 more items, and then more, that means that we're basically at the end, and we just have to resize again dynamically. So that's how our system is going to work. Yeah, so it's going to basically allow us to basically push. So we're going to have functionality to essentially push items to array, pop items from array, and we'd also be able to essentially push items items at a specific index, right? At a specific index, and then also pop items from a specific index, like so. Okay, and then the list will also have auto resizing. So auto resizing, it will basically just resize itself. Resize. Am I even spelling that right? Auto resize, like this. Nah, I think this is it. I don't know, guys. But yeah, right, it will auto resize itself. So auto resize auto resize, like this. Come on, man. All right, so it'll basically have auto resize, and then also allow us to also clear the array. So you'll be able to just call a function to be like, hey, clear this array, but then still keep the capacity. Okay, so this is what we're gonna have, and this is what our dynamic array list is going to support. These are the functions it's going to support. Probably I can add more, so we'll see as we go, right? So let's get started. So what I want to do is in our source directory for our engine, we want to add a new folder, and we're going to call this containers. Okay, and then inside here we're going to create that new container for ourselves, right? So what are we going to call it? It's going to be a dynamic array. So since C doesn't really have the concept of arrays or vectors or whatever, you basically can call it anything you want. So I'm just going to call this an array. I know that it's a dynamic array, so yeah, so I'm just going to call this array. I want to say array.h, and then I'm going to do array.c, like so. And yeah, I don't think we'll be going to be using any external libraries that could potentially conflict with these names. That's because we're basically going to be building most of the stuff from scratch anyway. So yeah, anyway, so in the header file, all you want to do is just say pragma once, and in fact in here then you want to also just include it and then be like array.h, like so. Okay, and then I'm gonna close all of this. Actually, I'm just gonna rebuild this, just make sure that my IntelliSense and everything is perfectly working. So what do we need? So we're gonna need a struct to essentially hold this header. Okay, so this video might be long. I really don't know, because this will be a very long video. Hopefully not, but we'll see. All right, so I'm gonna create a struct to be the header for our array. So I'm gonna do type diff struct, and then I'm gonna say array header, like so. And then I'm just gonna copy this name, paste it over here, and then in here what I'm gonna do is I'm gonna say actually I need to include my defines.h file, and that is in platform/defines. I need to remove it from there, but I'll do that in a different video, I guess. Yeah, and then what do we want to do? What metadata do we want to store in here? And again, I don't have proper syntax highlighting in here, so I'm just gonna save that, close this, and then try and rebuild this again. Hopefully it will work now. And just close this and come back in here. Yeah, there we go. All right, so what I want is I'm gonna have a u64, and then it's gonna be called capacity, right? And this will hold the capacity of our array, and then we're gonna have a u64. Okay, and then this will be the count. So yeah, the number of elements. So I don't know if I should go with count or array or length. What do you guys think? Count, length, does it really matter? Yeah, I'll stick with count. And then what we're gonna do is we're gonna say u64, and then I'm gonna do stride. This will be the size of the element that we're going to be storing in this array, because we want to make it generic in the sense that we can just be like, hey, create me an array of integers, or hey, create me an array of booleans, or create me an array of a custom struct. Okay, and then it will handle everything for us, right? So yeah, these are the metadata that we're going to be storing in this header, right? And then from there we're going to need some macros. So I'm going to do define define, and then I'm going to define like dynamic, let's call it dynamic. We want like the default capacity for the dynamic array, so I guess we can just say dynamic array default capacity. Dynamic array default capacity. That's pretty lengthy. And we'll have a default capacity of 1, and then we're gonna have another macro. So we're gonna be like dynamic array resize, because we wanted to basically have auto resizing, so we're gonna have a resize factor of 1, like so. And then down here we're going to define some functions, some internal functions we're going to use internally. Can maybe refer to these as some helpful functions that we'll call using macros. So we're going to do void pointers, because they'll be returning void pointers. So we're going to be like array create. So this one will create an array for us, and then it's going to take in a U64 count, and then it's gonna be like there's your capacity, right? Yeah, there's your capacity, and there's gonna be a U64 stride, like so. And then yeah, I think that's it, right? And then we're gonna duplicate this a couple of times. And then we're gonna have array create, then we're gonna need like a function to resize, and then all we're gonna be passing in here is the array itself. So let's do void, and then just say array, and then so we have the resize, and then we're gonna need to do push, right? Because we need to push some items and pop some items. So we're gonna say push, and then we're basically just gonna pass in the array. So we're gonna say push void pointer array that we want to push to, and then essentially we're gonna pass in the value that we want to push to. So that will be a pointer as well. In fact, it will be a const void pointer, because we don't want to modify that value. And then we just say like this to indicate that it's a pointer to some value. And then we now have push. We now want to also do like push at index. So push at does that sound nice though? Push at push, and then push at, yeah, I think that's fine. And then all you want to do here in the middle is just pass in a U64, which will then be the index. So we're going to push at that index this value, okay, that we're going to pass in there. And then after that, we're going to do some helper macros that we can actually use to call these functions. We're not going to call these functions directly, so we're going to call them through macros. So I'm going to define a new macro here, and I'm going to be like array create. Notice that it's the same name. Notice that it's the same name, except it doesn't have this guy in front of it. Okay, so it's just going to be array create, and then here is where the magic happens. So instead of us having to pass in two things, we're going to automate this and be like, you can just pass in the type of array that you want to create, right? For example, you want to create an array that holds integers, so all you're going to be passing in here is the type. So you're going to pass in int, because you want to create an array of integers. So you're just going to pass in the data type like this, in this case being an integer, and then this will just fill out and call this guy for us automatically, and it will create you an array that can hold integers. All right, so yeah, so let's do that. So it's going to be like array create, and then you're going to pass in the type, the data type, and then we're going to take that, and then all we're going to do is we're going to cast to that type, right? And then we're going to call array create, and then inside here we're going to create an array with a default capacity. So we're going to say dynamic default capacity, and then we're going to also say size of, this will then give us the stride, and then it will also create the array of this data type, okay, that can hold these data type, the size of this data type, I mean. So let's do size of type, which is the data type that you just passed in there. And then that's it, right? And then we're going to create another macro down here. So we're going to do define array, and then I'm going to say reserve, because now instead of just creating an array with the default capacity of 1, you can also just basically pass in at the capacity that you would like. So for example, you want to basically create an array with capacity of 20 elements, right? They can hold 20 elements. Then you can just reserve space for 20 elements, right? This is what we're doing here. So we're saying array reserve maybe 20 space for 20 elements of this specific data type. Okay, so what you want to pass in here is the data type and then the capacity. Okay, so capacity, like so. And then all we want to do here is also just cast this to the type. So I'm going to do type, then I'm going to call array create, right? And then instead of passing the default capacity here, we're going to pass in the capacity that you pass through. All right. Yeah, so capacity, like so. And yeah, make sure the spelling is the same. And then we're going to do size of the data type that you pass through. Make sense? All right. Then all we want to do next is we have create resize. We don't have the resize yet. In fact, the resize we won't actually call using a macro, but the push we might call using a macro. So let's do define array push to allow us to push items. And then in here, all we want to pass in is essentially the array itself. So we're going to do array and then the value that you want to pass or push to the array. And then that's how we're going to do it, right? And then the way that this is going to be is we're going to open up a body here, and then we're going to do type of, and then we're going to do let's do the value, and then we're going to create a type variable, and then essentially that make that equals to the value that you pass it in. And then all you're going to do next is we're just going to say array is equals to array push. Okay, and then all we're doing now is just passing in the array that you want to push to along with the variable that you want to push to, like so. All right, and notice that it gets formatted. So let's do the slashes here so that it knows that this is part of a macro. And then when I save this, it will do this. So what I'm going to do is I'm just going to put another one here just so that it condenses it a little bit inwards. And then all we're going to do next is essentially create another macro, and this one is going to be called push at. So we're going to push at the specific index. So we're going to do define array push at, and then all you want to pass in here is the array that you want to push to. So I'm going to say array and then the index along with the value that you want to pass. And then I think we can just copy paste this method here. I'm going to copy paste it down here because essentially it's just going to be the same thing with a slight change. So this line is going to be the same, and then the only thing we're going to be changing is here. So I'm going to say array push at, and then all we're passing in is the array that we want to push to, and then the index that we want to push to, and then everything else should fairly be the same. All right, sweet. So now that we have that, we're going to have to define some other functions that we are going to use. And we're going to create a void, and then this one will just be a function to basically destroy the array. So void array destroy, and then this will take in the array that we want to destroy. So let's do array like so, and then we will just simply come down here and be like void array pop like so, and then essentially we'll just pass in the array that we want to pop an item from. So the array, and then Now, the way that we want this API to work is, for example, let's just say we say array pop, and then we pass in the array that we want to pop from, right? Like so. What this will actually do is it'll go through this array that we're passing in, and then it will essentially just pop that element that we want to pop, or the last element that we added. We'll just remove it from the list, and that item will be deleted, thrown away, or whatever, right? But sometimes we want to keep that element, but not in the list, but somewhere else, right? So we want an ability to essentially be like, hey, if I'm popping an element, I want to pass in a destination to pop it onto, right? So if I pop it off the list, I want to store it somewhere else, right? So we want to add that functionality. So what I'm going to do is now I'm going to pass in the ability to essentially just pop it off to a specific destination, okay? Yeah. So we're going to do it like this. So now, instead of just passing in the array that you want to pop an element from, you also pass in the destination. So for example, you could have an array of integers, and then you could just have a variable called a that could hold a number. And then for example, now you can be like, hey, I want to pop whatever the element that I'm popping from the list, and I want to basically store that in this array, in this variable. And then it will remove it from the list, and then just take that element and just store it in this variable. And now it's away from the list, but now it's stored here. Okay, makes sense? Sweet. So this is what this will do. Now this will be optional, so if you don't want to store it somewhere else, you don't have to pass in a destination, but it's just there in case you want to. Okay, so we have a function to basically pop an element, and then we also want to essentially be like void array pop pop at, essentially, and then we basically gonna pop an element at a specific index, right? And what you want to do here is just pass in the array that you want to pop from, and then also just do a U64 to basically pass in the index along with the destination, because sometimes you want to store that popped element somewhere else. So let's do a void dest like so, and then close that off. All right, and then all you got to do next is essentially just do we have pop at, oh no, this is my bad, array pop at, and then we need to essentially have another function here. This one will just be like our an array, an array clear. And we'll just essentially just clear the dynamic array. So let's do void, and then just pass in the array that you want to clear, like so. And then we'll have some helper functions down below that will give us some metadata values, because here we have the header, and then it has data for the capacity, count, and the stride. So we want to have access to these values. So what we're going to do is, since they're all U64s, so we're just going to return their values. So we're going to do array capacity, well, array get capacity, like so. Then I'm just going to pass in the array that I want to get the opacity of, and then I'm going to just copy this a couple of times, and I'm going to say get count. So this will basically give us the number of elements in that array, and then we're going to also do get stride. So get stride, and this should be fine. And then if I save, then all we're going to need is another function here that will just be like array count set for when we resize and other things. So we can just explicitly set the count, the number of elements in that array, whenever we resize or remove an element or something like that, right? So then we're going to pass in the array that we want to modify the count for, and then we're going to do we're going to pass in the value that we want to set the count to be. So we're going to do U64 value like so. Okay, sweet. So I believe when we have things like this, we are essentially on the right track, right? So yeah, so I'm gonna save this file, and then I am gonna go to the implementation file and just copy paste some of these functions into the implementation file, like so, right here. And then just copy paste these, and then go down there, and then paste them like here. And then this is where we're gonna fill out what we need to fill out. Now, some parts of the code I might explain, some parts of the code I might not explain, because this is where things get a little bit messy. And the method that I'm basically going with here is one inspired by another YouTuber called Travis Furman. He has a YouTube channel. He's a very brilliant guy. Let me say man, because he's pretty older than me, but he is very, 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 very talented, and he's building his own very game engine as well. This man right here, Mr. Travis Furman. So yeah, this is where I'm taking inspiration from. So if you guys want to also build your own game engines and learn even deeper knowledge, I would suggest that you basically subscribe to Mr. Travis from his channel here, and watch his videos. Most of the stuff that I'm going to be doing will be heavily inspired by his implementations, so you guys can definitely check out his channel. I would say that his channel is a little bit more advanced, but it could still be useful for you guys. So yeah, all right. Yeah, so this is where I'm going to take inspiration from. I'm taking it from how he implemented a similar thing in his engine as well. So I'm going to take inspiration from that. Okay, so yeah, so let's get this ball rolling. So anyway, oh, my mic almost fell. Oh, my mic almost fell. That's not good. But anyway, we're back. Yeah, so let's implement this function. So the way that I'm going to do it is, yeah, we are basically going to set up this header file first. This header struct. Yeah. So we're going to do a U64. Then we're going to get a header size. And then that will be equals to size of array header, like so. And then we're going to do U64. And then we're going to have the array size, and then that will be the count, the number of elements multiplied by the size of each element. So that will be the array size. And then what we're going to do next is just have an array, and we're just going to say new array. Essentially is going to be equals to, we need to malloc memory for this, so let's do include stdlib, and then I'm going to do count capacity. Oh, okay, let's do capacity, and then let's do malloc. So I'm going to do malloc like this, and then what I'm going to do, I'm going to say header size. Okay, this is the memory that we're going to allocate for our container. So it's going to be the size of the header plus, right, the array size. Okay, so let's do y. Oh, here we go, array size. Okay, so that's the block of memory that we're going to initially allocate. And then we're going to check if that block of memory really got allocated. So I'm going to say if new array does not exist, and then we know something went wrong. So I'm going to include our logger system here. So I'm going to do core/logger, and then what I'm going to do is I'm going to say L error, because this is an error. So let's do oops, I'm going to say array creation failed. Let's just make this lowercase. Array creation failed. Or rather, let's do array memory allocation failed, something like this, right? And then we're going to return 0 because this function should be returning a void pointer, but since it failed to allocate some memory, we're going to return 0. And then if the array really did get created, all we want to do is just set everything in this container to 0 so that we don't have garbage values everywhere, right? Everything should just be set to 0. So I'm going to do new array. Then I'm going to set everything in that array to 0. And then I'm just going to give it the size of that container to set everything to 0. So what is this? Array size. Keep forgetting. All right. Then once we're done there, what we want to do is essentially do array header. And then what we want to do is say header equals to array header. I'm just going to cast this. And then I'm going to say new array. And then what I want to do is set the header properties now. So I'm going to do header capacity equals to capacity that I passed in there. And then I'm going to say header dash count. And then we're going to have 0 elements initially. And then we're going to say header, and then we're going to do strad, and then it's just going to be the strad that we are passing in when we call this function, like so. And then all you want to do next is just simply return, and then what we're going to return essentially is the new array. And then the way that I'm going to do this is I'm just going to say new array, right, and then plus header size, like so. And then I'm going to cast this to a void pointer because it needs to be a void pointer. So I'm going to do void pointer, and also essentially where should I put this, inside or outside these brackets? I'm going to do a u8 pointer, like so. And then I'm going to close this. Sweet. Yeah, like that. Okay, save this. And then this function right here will just create a new array of the data type that we pass in. And it will just allocate the block of memory needed initially for that array. Right? In this case, it will have a capacity of 1, 0 elements. And from there on, we can basically do the other stuff. So let's go ahead and let's do the, I think I'm going to skip the resize for now. Let's do the push so that we can at least push elements to this. So let's do the push. So let's come down here, open up this guy, and then what I want to do now is I'm just going to say I'm going to get the header. So I'm going to do u64, and I'm going to do header size. So header size equals to size of, actually I could have just copied this from up here. Yeah, so just paste this in here. There's no need to retype all of that. Yeah, okay. And then all we're gonna do is say array header, and then header equals to array header. Just cast this. Did I do that here? No, I did not. So array header, and then that will be a u8. So u8 pointer, and then all we want is to essentially say array that we pass in, and then we're just gonna subtract the header size from that, and then we will have our header. And then from now that we have our header, all we can do is say header, and I'm going to check if the count is greater than or equals to the header capacity. And then if that's the case, essentially we need to resize, isn't it? So the way I'm going to do this, I'm just going to say array equals to dynamic array. So array resize. Okay, like so. Then we're gonna pass in the array that we want to resize. Okay, and then now that we've basically resized our dynamic array, all you want to do is then get the header again. So just set the header. So we're gonna do array header, then cast this. Okay, then I'm gonna do this, then I'm gonna say u8, cast that, then I'm gonna do array, I'm gonna say minus header size. Okay, then I'm gonna close this off, and that will be fine. And then the other thing that I want to then do is essentially I'm going to do a UI int pointer here, UI int pointer, and then I'm going to call this the address that we want, and then I'm going to say UI int pointer, and say array, address equals, yeah, like so. Okay, then I'm going to say address plus equals to header count multiplied by the header stride. Okay, and then all we want to do is just do a mem copy, and then we're going to do void pointer, and then we're going to say address. I'm going to copy the value that you're passing in to that position in memory, and then we're just going to say the size of that will be the header stride, like so. So that's how we would basically just copy memory into the array. Okay, just offset the address to the location in which we want to basically copy the value to, and then just copy it to that. Okay, and then after copying, we actually want to increment the number of elements now. So all you have to do then is just say I think we can call a function for this that we actually created. So I think it was array length or count, right? Length count set. I actually want to rename this. So let's do set count like this. Actually, I think that's a better way of using this. Yeah, so set count, and then we're gonna pass in the array that we want to set the count of, and then all we're gonna do is just say header count. Nope, not capacity, count. And then we're just gonna increment that by 1. Okay, header count plus 1. Okay, that will be the new count. And then we're just gonna return the new array. Make sense? Sweet. Yeah. Yeah, so now we have the ability to push an element to the list. What I need to do is implement the resize, because we're now making use of it in there, so I actually need to do that. But I'm not going to retype this because I'm going to need it here, so I'm just going to copy paste it over there. And then all I'm going to do is when we resize, we need to check something. So we're going to do a header. Then we want to check if the capacity is equals to 0. Okay. And then we're going to do error. And then we're going to do array resize called on a list with 0 capacity. Okay. Yeah, and then this should not be possible. Okay, because we can't multiply 0 by something, because a resize, the whole point of a resize is essentially just to either double the capacity or multiply it by some factor, right? So anything multiplied by 0, well, it's 0, right? So hence we're putting this check in here. So return 0, like so. However, if the capacity is not 0, then we're going to move on. So I'm going to say void temp, and then I'm going to do I'm going to create a new array. So I'm going to say array create. So we're going to have a temporary array. And then the capacity of this now will be the dynamic array resize factor multiplied by the header. And then we're just going to take in the capacity that we have currently, and then we're just going to basically multiply that with the resize factor. And then that will be essentially, let me just encapsulate this. That will be the new capacity of the array. And then the header stride, the stride is actually stored in the header itself, so we don't have to pass that in from the function itself. So then we're going to do we're going to check. Okay, so we're going to check if this was successful, right? If that memory did indeed get created, like in this case, a new array. And then if it did not, then we're just going to print out an error message saying array resize failed to create temp array. Okay, this is just for us to notice that I put a new line there. We don't need it. And then all we do next is just return 0, like so. Okay, so now we've done the necessary checks to basically check if we can indeed resize, and then if so, then we just create a new array with a new capacity. And then all we want to then do is just say array header, and then new header equals to array header, like this. Then we're going to do u8 pointer, then temp, then we're going to say minus header size, right, like so. Is this readable enough for you guys? Or do you guys want me to just do this? Yeah, I guess that's better. Yeah, okay. Then all I'm gonna do is I'm gonna say new header, and then I'm gonna get the length, so count in our case, and then we're gonna do equals to header slash count. So we're gonna set that like that, and then what I'm gonna do is, again, nope, not that one, memcpy, just copy some memory, so to that new array that we created. So new copy memory to this array, and then the memory that we're copying over is from the old array, and then the size here will then be header, that will be count multiplied by the header stride, like so. Okay, and then all we want to do, say our dynamic array, is essentially just destroy our dynamic array. So array destroy, and then the array, the old array, and then we're going to return the new array. Okay, like so. Make sense? Sweet. So now we can push to the array and resize if we need to resize automatically, without us having to worry about the thing. And then I think what I want to do is I want to set up these helper functions real quick. Yeah, so let's set those guys up real quick. In fact, let's set up the destroy first, because when we resize, we need to destroy the old array. So let's do this guy first. So array destroy should be simple. So we're going to check if indeed the array that we want to destroy does exist. So if it does, then we want to do the following. So we're going to do AU64. Actually, I don't have to type this again. Just copy this. So paste it in here. And then all I'm going to do is just free. So yeah, I'm just going to free this. So I'm going to do free header. Makes sense, right? Array destroy free. And yeah, that's really it. And then all you want to do next is these guys. So let's do that. Um, do, 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 do. Let's see. How will I? Okay. Let's do. In fact, let's just do this one first because this one is pretty easy. So clear, we're not really deallocating any memory. So we're just gonna be basically just say dynamic array set count. We're just gonna set the count to 0 essentially, right? Yeah. So the array that we want to set the count of, and then we just set that to 0. That will just move where we start to add elements all the way back to 0. It'll just override that memory with new data as we go ahead and add new elements to the list again. Because the capacity will still be there. We're not deallocating any memory. We're just overriding whatever it is that we want to override. So yeah. What else? Capacity. So the way I'm gonna do this one is I'm just gonna copy this, and then in here we're just gonna set the capacity. Ooh, this is a typo array. So let me just make sure that this does not bleed all the way through here as well. Yes, it does. So let's just get rid of that extra R. Array. So everything else is there. I don't like having typos, so sorry about that. And I noticed that here is there as well. So sweet. All right. So array get capacity. This will just give us the capacity. So it's pretty simple. All you do is just say header, return header capacity, like this. Simple, right? And then the get count is no different, so it's pretty easy as well. So all you do, instead of returning capacity, just return the count, like that. Simple. And then the stride, same story. Instead of returning the capacity, just do stride. All right. And then array count set. This one is also just straightforward. Instead of retrieving, we just setting. So we're gonna do header, and then we're just gonna say count is equals to the value that we pass in. Beautiful. Okay. And I think that is all that we need for now. So we can basically add elements. We can resize the array, and then the only thing that we need is be able to add at a specific index and as well as pop. So for the pop situation, I think that's also pretty easy. So we can sort of like try and add that now, so that we can test all of this, right? So let's do the pop. And then all we want to do is when we pop, essentially, we want to get the count and the stride. So we're going to do U64, and then that will be making use of the new functions that we've just created, the new helper functions. So we're going to do count equals to array get count, and then we're just going to pass in the array that we want to get the count of, right? And then we're going to do another U64. And this one will be the stride, and then we're just going to say array get stride, and then we're going to pass in the array that we want to get the stride of, and then from there we're going to do this. I'm going to say if count, right, is less than 1. Okay, if it is less than 1, all you want to do is just do error, right? Because if you don't have one element in there, what are we popping? Right? We need to at least have one element in there to pop. So in this case, if you don't have any, all you're gonna do is print out a message and be like array pop called on an empty array. So nothing to be done. Right, so there's nothing to be done in this case. Okay. And then all we gotta do is just do a normal return out of here. And then that's about it. Okay. And then what I need to do is essentially pop the element. So we need the address of that element that we want to pop. So I'm going to do another UI int pointer. Then I'm going to call it the address. And then we're going to say UI int ptr of the array. Then we're going to get the address. So the address plus equals count minus 1 multiplied by the stride. So actually just want to encapsulate this, close it off like that, and then I'm going to do if, right? So we're going to get the destination, the address I mean, and then if we passed in a destination, so if we passed in a destination, all we want to do is just copy that element to that destination. So we're going to do a mem cpy, and then we're going to copy to the destination the element that we pop in off the list, in this case the element at this specific address, and then the length, the size would just be the stride, and then that should be it really. So we only copy pasting to the destination if the destination is actually passed in. So if this is 0, this will not get called. Yeah, and then all we have to do after that essentially is just just set the length, the count of our array. So we're going to do array set count, right? And then we're going to do array, and then I'm going to say that will be count minus 1. We're not deallocating memory, we're just moving 1 bit back, and then we're just gonna override that memory once we add a new element. So yeah, I think that's it really. Yeah, that's it. So then that leaves us with only this function to implement, and this one, the push at and the pop at. Now before I do these guys, the push at and the pop at, I actually just want to like essentially test this out. Right? Yeah, I just want to test this out. So the way that I'm going to test this out is I'm going to go to main.c, and up here I'm just going to include that new container. So I'm going to do containers / array, and probably maybe here we're gonna create, I don't know, let's see, an array of numbers. So I don't know, let's just call it numbers, and then that will be equals to array create, and then it's gonna be an array of integers like so, and it's gonna cry. That's because this needs to be a pointer, because this returns a void pointer. So now that we have the array, all we can then do is be like array push, then I'm gonna pass in the array that we want to push to, then I'm gonna push maybe 5, and then all I'm gonna do is I'm gonna push a bunch of numbers. In this case I'm gonna push 4, 3, 2, and 1, so like so, right? And I'm getting errors here. Use of undeclared identifier array. Oh yeah. Let me see what is going on here. Alright, so I figured it out. The issue was that we had a typo in our macro, and unfortunately sometimes when you have typos in your macros, you don't necessarily find those issues very easily. In the case of VS Code, it actually did catch that in this file. It's just that I did not read my expandation, this expands to message properly, but the error was there. However, when you compile, the error doesn't really show up in the compilation messages right here. So just keep that in mind. So if you do make some mistakes in your macros, just know that sometimes you will not get help from your compiler. So yeah, but anyway, now that we have that fixed, we have new issues that we need to deal with here, and it says undefined symbols. So let's go back into our header file, and it says array set count. So let's see, function definition is not found. So let's just copy this, and let's come back down here, because I do believe that we did change this, and yes, we did change it. So let me just create some spacing in between here, and then I'm gonna save this, and I'm gonna try and run this again. Hopefully it should work. It says array size called in a list with zero capacity. Let's see, our default capacity is 1. Resize factor should be 2, so we're multiplying by 2 every time we resize. So it's 1. So let me rerun this again. Zero capacity. Well, that's funny. So let's go here where we create the capacity. Let me just replace this with 1. And here with 1, and then let's save, and let's make this again, and we still get the same issue. Wait, let me see, am I doing a mistake here in one of my it's probably, yeah, I need, see how I have encapsulated this here, but I didn't. I need to encapsulate everywhere where I'm using this. Okay, that's fine. This needs to be encapsulated within parentheses because we're casting it in the end as well. So let's see, where else? Here as well. Yeah, and I guess for all these functions, because I copy pasted this. So just make sure, it will just ensure that the casting is casting properly. And then this should probably get rid of this, because I feel like it's just not getting those values accordingly because of the offsets and stuff. So let's just remake this, and we have a new error. So pointer being freed was not allocated. Pointer being freed was not allocated. So let's see. Copy. This is not, oh yeah, destroy. This is where we're freeing, so it's also not getting that properly, the index. So let's remake this, and yes, so our list is working. So let's go back to the main file, and in here we've basically pushed 1, 2, 3, 4, 5 elements. So let's do l info debug print, l info print, and then it should basically say something like number of elements in array, and then we should do a d here, and then let's do array get count, and then the array that we want to get the count of. And this is actually us testing if our logger can handle what do you call these arguments? Because we didn't really test this ever since we created the logger, so I guess we are testing that now. So let's rerun this again. Let's see. Right now it says number of elements in array is 5. Do we indeed have 5 elements? 1, 2, 3, 4, 5. Yes, we do. So if I add another one, or if I add 0, let's do -1. Well, can we have a -1? 1, 2, 3, 4, 5, 6, 7. So now it should say 7 here. So let me quit the window and then make this again. We should be seeing 7, and we are seeing 7. So number of elements in the array is 7. So we are creating an array. We are able to add elements. So let me do another print, and then just before that print, I'm gonna remove. So I'm gonna do array pop numbers. Okay, then I'm gonna pop the last number, and then the destination is 0. We're not really saving that off to anywhere. So instead of 7, we should see 7 initially, and then we should see 6 afterwards. So let me save this and then close my window and then rerun this bad boy like so. And close the window. And now, so initially it's 7, then I remove 1 element, then it's 6. So let's see if this removed element can be stored somewhere. So let's do an integer, and then I'm going to say number, I guess, and then be like, okay, I want to store that number that we're popping off to some variable. So in this case here. So let's rerun this again. So let's clear console, make, and let's see. Oh yeah, we won't see the number itself because we're just storing it, but we're not doing anything with that information. So let's do an L. Let's do a 1 just so that it's different color, and then popped number is, and then popped number value is the value of that. So let's do number. So this should be populated with that popped off element. In this case, it should be a -1 because we pop in the last element. So let's do a make, and let's see. So popped number value is -1. Yay! So now that that works, let's do again. So probably should now see 0 there. So just to double make sure that everything is working. Yay! So pop value is 0, so because we popped up that value now, so it is working. So our dynamic array does work. However, we still need more functionality here, and I'm pretty sure the video is a little bit long now, but it's fine. We're almost done. We just need to implement the pop add and the push add and the pop add. So those are the only 2 functions I believe are still pending. Yeah, so let me do that. So let's do push add first. And the way that I'm going to do this is I'm going to take this, because I'm just going to paste it in there. And then what I'm going to do is now I have the count and the stride, and then all I'm going to do a check here, and then we're going to say we're going to check index. Then we're going to see if the index is greater than the count, then obviously we out of bounds, isn't it? Right? So we're going to do L. Is it an error or a warn? It's an error message, right? We're out of bounds, so we shouldn't be accessing memory that we can't access anyway. So let's do index outside what? Outside the bounds of this array. Okay, and then we're just gonna print out some metadata. So length is D, and then the index that you passed in is also a D decimal number. So the length will be the count, and then the index will be the index that you passed in, like so. Okay. And then I think that should be fine, and then we should just return the array. Well, I guess we can just do warn here, maybe. I don't know, because yeah, we're not crashing or anything, right? Yeah. And then, so now that we know we're handling the index situation, we need to handle another situation, and that will be if the count is greater than or equals to array get count of the array. Then we have a situation. So we're just gonna say array is equals to array resize. Then we're just gonna resize this. guy here as well. And then all we need to do then is do another UI end pointer, get the address, right? And then that will be UI end ptr, and then that will be array. And then all we gotta do is, now I don't know if I should use a mem cpy or a mem move. Which one is efficient? Mem cpy or a mem move? I guess I'll just do a mem cpy. And then this is gonna be a little bit tricky. So I'm gonna try not to screw up this. Yeah, so I'm gonna do a void pointer. Yeah, and then I'm gonna do this. Then I'm gonna say address. Again, I'm gonna try as much as I can not to screw this up. And then I'm gonna say address. The address, and then we're gonna do index +1. And then I'm gonna go outside here. I'm gonna do stride. Then I'm gonna do a copy. I'm gonna do void. I'm gonna cast to void. Then I'm gonna do my open bracket. Then I'm gonna do the address. Okay. Then I'm gonna say plus. Then I'm gonna do plus the index multiplied by the stride. Okay. 2 out there. Then we put another one. Then we're simply gonna say stride. This is going to be the size. So stride multiplied with count minus the index, like so. Okay. Hopefully I did not screw this up. But anyway, otherwise it will be catastrophic, right? So yeah, and then from there I'm just gonna put a comment here. Set at the index. So then we're gonna do mem cpy. Then what I'm gonna do is cast void. Then I'm gonna do my address, and I'm gonna do, I hate memory. I really hate working with this memory stuff, but we have to do it anyway, right? So I'm gonna try not to mess this up. So value pointer, and then stride the element, and then after copying the value into that block of memory, all you want to do next is just update the length. So array set count, set count to the count +1 actually. And then I think instead of returning 0 now, we can just return the array. And hopefully that should work. Yuck. Yeah, this is not what I like to do, unfortunately. So let's just test to see if we can actually pop an element at that specific index. Let's see. The only thing that I'm not doing at this point is with pushing, not popping. See if you can push an element to that index. So let's go to main.c, and then what I'm going to do is I'm going to say array push at, and then I'm going to say numbers, and I'm going to push this between 5 and 4, so that'll be 0, 1. So I'm going to push at that index, and the value that I'm going to put in there is going to be a big number, so let's do 20, so that we can indeed see if that actually worked. Then instead of removing anything here, I'm just going to see 1, 2, 3, 4, 5, 6, 7, 8. We should be having 8 elements. So yeah, should be having 8 elements. So let's see. yes, we do have 8 elements, and I'm gonna pop. So, and I'm gonna store that value somewhere. So number, I'm gonna do array pop, and then I'm gonna pop. Ooh, yeah, I can't do that because we're in here. We can't pop at a specific index just yet because we haven't implemented that. So what I'll do, instead of adding it in between 5 and 4, I'll add it 1, 2, 3, 4, 5, 6, 7. So 0, 1, 2, 3, 4, 5, 6, 7. I'll add it at the 7th position. So let's see if that will actually work. 7th position, and then I'm just going to, it's going to tell me that I have an unused variable. So let's run this, and then we should see 7 elements. So 1, 2, 3, 4, 5, 6, 7, and then 8. So this didn't get called in because we actually pushing towards the end. So I guess that doesn't really, you know what? You know what? Let's do 6. Yeah, let's do 6. Okay, and then it should say 8. Yes. So then what I'm going to do is I'm going to pop array pop. Then I'm going to pop numbers. Then I'm going to store into this number here. And then I'm going to do L warn. Then I'm going to say value. Let's do a D, and then let's do array pop. Oh, no, not array pop, number, like so. Close this. Okay, and then we should see the number that's being popped. Okay, then I'm gonna do 2 pops. So save this, and then let's rerun this and see. So we pop -1. Okay, then the next one should be 20, and we do. Okay, yes, so it is working. So push at is actually working. Magnificent. Okay, next, the last one is pop at. Now, pop at essentially is going to be somewhat the similar, but the opposite of insert, right? We're going to be popping. So what I'm going to do, I don't know how much code I can actually reuse from this. So from the insert at. So what I'm going to do, I'm just going to copy all of this. Insert at, I'm going to paste it in pop at, right? And then I'm just going to do slight changes here. We're still getting the count and the stride, and we're still checking if the index is greater than the count. Fine. Then we still need to basically get the address. Index greater than that. So pop, we don't really need to resize when we pop because we don't want to deallocate any memory. So get rid of that. Then the address situation should still be the same, and then the only thing we need here is the destination. So when we pop at, we also want to have the ability to essentially save off the value. So we're going to do memcopy destination of that value. But now, because we're popping at a specific index, we can't just say this on its own. So I'm going to put this inside parentheses like this. I'm going to say address plus, then we're going to do index, okay, multiplied by the stride like this. Okay, that should then give us the value that we're looking for, and then that should be fine. And then the only thing we need to then do is to check if we're not, let's see, where do I want to check that? Do we do a memcpy? Yeah, before we do the memcpy, we need to check a condition, right? So let's do an if statement. So let's do if, And then I'm going to say if the index, right, it's not equals to count minus 1. Okay. Then I'm going to open this up. Then we can copy. Okay. Like so. Make sense? And then do I need to make any changes to this though? I don't know. Let's see. Yes, I might have to, or might not have to. Let's see. Void pointer address, then say index multiplied or edit by 1. So instead of essentially let me see. So void pointer address plus index. So instead of adding this by 1, I'm simply just going to multiply by the stride. So it's going to be memcpy void pointer address plus get rid of the extra parenthesis. So it's going to be address plus index multiplied by stride, which is what we're doing up here, right? And then what we want to copy is void address plus index. I guess this is where I'll put the +1 at. So let's do that here. And then I'm going to say address. Wait. Yeah, I'm going to say index +1. Okay. And this should be closed off like this actually. Let me remove here. I'm sorry about that. And then we're just going to multiply that by the stride. And then we should go out of here. And then there should then be stride multiplied by count minus the index. So let's also fix this. So it should then be index minus 1. Like so. CPY is now crying. Functions. Let me see. Open, open, close, open, open, closed. So I need another one here. That should fix it. Yeah, that should fix it. Okay. Then we should then, okay. So after checking, we then do this. Do we still need to do this below? Yeah. I really hate this. Okay. Actually, no, we don't need to do this. So, so after moving that, popping that, we can set the count, array count, and then we subtract because now we removed an element. And in fact, I think, oh yeah, I am doing it correctly there as well. I think this is it, right? Yeah, then we just return the array. So in our main.c, we can now do pop at, and then I'm going to pop an element at the 6th index, which is that 20 that we want to pop. And then I'm just going to do this real quick. Okay, let's see if this will work. And then I'm going to close the engine, rerun that. Hopefully everything should still work, and the value that we popped off is 20. And it does actually work. So let me see if I can pop out like 4. So 4 is at 0, 1. So let's do that. Let's see. And then if I make, yes, we popped up 4. Sweet. And ladies and gentlemen, yeah, this video was very painful to make, but we now have a dynamic array. And this will be very useful in the coming videos. So stay tuned for the next video. So yeah, if you guys enjoyed this video, definitely hit that like and subscribe button for more, and I'll see you guys in the next one. So we have a dynamic container, and that will set us very well for the next new features that we're gonna add. Cheers.